So last class I was talking to you about the atomic weight, the relative atomic mass and relative molecular mass. I said you that relative atomic weight is a fractional number. For example, as I said you that for hydrogen we write it as 1. The atomic weight is, what is 1? 1 gram per mole. But actual atomic weight is, that is relative atomic mass, which we call it as 1.008. It is a fraction number, but we take it as 1. I said you that. Similarly for chlorine we take it as 35.5 gram, understood? But actually it is 35.453. It is fractional. Now the question comes here that why atomic weight is fractional? Because you see, atoms, a particular single atom, listen carefully, a single atom is consisting of several isotopes present in it. A naturally occurring atom consists of large number of isotopes present in it. You know what are isotopes? Isotopes are the atoms of the same element having same atomic number but different mass number. What I said you? Isotopes are the atoms of the same element, having same atomic number but different mass number. Now we will see it in higher classes that each and every element has got some or other isotopes present in it. For example, hydrogen has got 3 isotopes, 1H1, 1H2, 1H3. This is protium, deuterium and tritium. So you can see atomic number is the same, but mass number is different here. Mass number is different. Why it is different? Because number of neutrons is different in these cases. So these are known as isotopes. So what I said you, a naturally occurring atom consists of large number of isotopes present in it, and these isotopes are present in what you can say certain ratio by weight. Certain ratio. For example, you know the atomic weight of chlorine is 35.5 gram. We are taking it as 35.5. So now one atom of chlorine, listen very carefully, one atom of chlorine consists of 2 isotopes present in it. One naturally, what you can say, chlorine atom, naturally occurring chlorine atom consists of 2 isotopes. What is that? 17Cl35 and 17Cl37 in the ratio of 3:1. These are the 2 isotopes in the ratio of 3:1. Now how did we get 35.5 then? Because one isotope's atomic weight is 35, another is 37. Now listen, how we calculate the average atomic weight. Now what I am going to do, I am going to calculate the average atomic weight of chlorine from these 2 isotopes. From these 2 isotopes, I am going to calculate the average atomic weight of chlorine. I am going to calculate. So how it is? 35 into 3 plus 37 into 1 whole divided by 4. If you do it, you will be getting to be as 35.5. So hence the average atomic weight. So you can say the atomic weight which you are writing it here, it is nothing but the average atomic weight. Similarly, in case of hydrogen, the average atomic weight we are taking to be as 1. Because hydrogen consists of 3 isotopes, 1H1, 1H2, 1H3, protium, deuterium and tritium in a particular ratio. We can say that. When you calculate the average atomic weight, you will be getting to be as 1. So hence, for that particular reason, what you find is that atomic weight of this particular element, that is relative atomic mass, again I repeat, it is a fractional number whose unit is AMU, denoted with the letter U, small u, which is known as unified atomic mass unit, because it consists of several isotopes present in it. But when we convert it into gram, then it is a whole number. Why do we convert it into gram? Because to get the nearest whole number, and it will be easier for us to calculate. For calculation, it will be easier. Now, in case of chlorine is 35.5, because we have taken the nearest one. We have taken it. In maths, you have studied this particular thing, how to convert it in the nearest. Got it? The nearest whole number, how to convert it. So, this is about your atomic weight, which was left in the last class to be said to you. Next, we will come to the percentage composition. Now, what is percentage composition? What is the definition of percentage composition? Percentage composition is nothing but the percentage by weight of a particular element present in a given compound. It is the percentage, again I repeat, it is a percentage by weight of an element present in a given compound or a molecule. That is called as percentage composition. That means, suppose if I say a compound is there like sodium carbonate, Na2CO3. How much percentage is sodium? How much is carbon and how much is oxygen? because together it will be always 100%. Any compound together the percentage will be 100%, that you know it. Alright, so here it is being asked to calculate how much is sodium, how much carbon, how much is oxygen. So what I said to you, percentage composition is a percentage by weight of element present in a given compound or a molecule. Now the question comes, how do you calculate the percentage? It is simple, as you do it in maths, the percentage you calculate. Suppose if I want to calculate the percentage of sodium, if I want to calculate. So how many sodium is there? 2 sodium. What is the atomic weight of sodium? 23. Divided by the molecular weight of sodium carbonate. Molecular weight of Na2CO3. So that means what I can say, listen carefully here, listen carefully, that is number of atoms into the atomic weight of that element. So here number of atoms is 2, into the atomic weight of sodium is 23. Now this will be given to you. Atomic weight will be given to you, don't worry, by molecular weight of sodium carbonate. I'll say you how to find the molecular weight also. Now in this way you got the percentage of sodium. Similarly, percentage of carbon. Carbon how many is there? 1. What is the atomic weight of carbon? 12. This will be given to you, atomic weight. Again I repeat. Now molecular weight of Na2CO3. Okay. Now all you have to multiply into 100%, because you have to convert into percentage into 100%. Similarly, percentage of oxygen. Now this of course what you can do is that you will add this to percentage and subtract it from 100 to get the percentage of oxygen. That also you can do. But according to this formula I am saying you, what is that? How many oxygen? 3 oxygen atoms into atomic weight of oxygen 16. This also will be given to you, divided by molecular weight of Na2CO3 into 100%. That means what is the formula? You got it? To calculate the percentage of any element, number of atoms into the atomic weight divided by molecular weight of the molecule or the compound into 100%. Again I repeat, number of atoms, if number of atoms is 1, so you put it as 1 here, into the atomic weight, this will be given to you, by molecular weight of the compound, got it, into 100%. That will be giving you the percentage. Now the question comes here, how to calculate the molecular weight of Na2CO3. Now very simple it is. How many sodium is there? 2 sodium. So what is the atomic weight of sodium? 23. It will be given. Plus, along with sodium, carbon is there. How many carbon? 1 into 12. Plus, how many oxygen? 3. 3 into 16. Alright. Now you add it up this one. 46 plus 12 plus 48. So 8 to 10 plus 6, 16. 4, 4, 8. 1, 9. 1, 10. So 106 gram. You will be getting it. That is molecular weight of sodium carbonate. So you will put it as 106 here. You calculate this, you will get the percentage. In this way, we calculate the percentage composition of any element present in a given compound. Whatever is given to you, you will be calculating. I think it's clear to you what is percentage composition. Now the last one, empirical formula. Empirical formula. What is empirical formula? It is the simplest formula by which the atoms is present in a given compound. We can say that it is the simplest formula, or I can say it is the simplest formula. What I am saying you, empirical formula, denoted by EF. EF, empirical formula. It is the simplest formula. First of all, you have to understand it is the simplest formula. It is not the actual formula. The molecular formula is the actual formula. It is the simplest formula. What it tells you? Which gives the simple ratio of atoms present in a given compound or molecule. Simple ratio of atoms of elements present in a given compound, we can say that. So it is the simplest formula, and what it gives you? It gives you a simple ratio of atoms present in a given compound. For example, you know the molecular formula of sugar, the sugar which you are eating it. Got it? Sucrose, which is known as. What is its formula? C12H22O11. What is this formula? Is molecular formula. Similarly, if I ask you what is a formula of glucose, glucose is H12O6. What is this? Molecular formula. Okay, now if I ask you what is the formula of ethene, a particular substance, organic compound, its formula is C2H4. This all is molecular formula. Now, what you find is that now this cannot be further simplified. C12H into O11. You cannot simplify it further. You cannot divide by any number so that you will be getting a particular what you can say number. This is the molecular formula. This is also the empirical formula because it cannot be simplified further. So molecular formula and empirical formula both are same. But here in this case you see, in case of glucose you see very carefully. What we can do is that we can divide it by 2. So 6 and we can cancel this. There's a 1, 2 and this is 1. So what is the ratio I got it here? Carbon is to hydrogen is to oxygen. What is the ratio? 1 is to 2 is to 1. So as a result, what is the empirical formula I got it? CH2O. C is 1, hydrogen is 2 and oxygen is 1. CH2O. This is your what? Empirical formula. Again I repeat, C6H12O6. This was your molecular formula. You divide it by 6. You can divide it. What you will get it? 1 to 1. The ratio you got it. The simple ratio. Carbon, hydrogen, oxygen 1 to 1, 1 is to 2 is to 1. Now what is the empirical formula? This is the empirical formula CH2. So it gives the simple ratio of atoms present in a given compound. Now here in this case you see, you divide it by 2. So it is 1, this is 2. So what is the formula? Carbon and hydrogen, how much I got it? That is 1 is to 2. So what is the empirical formula I got it? Empirical formula I got it is CH2. CH2 is the empirical formula, carbon 1 and hydrogen 2. So empirical formula, it gives the simplest, it is the simplest formula. It gives the actual number of, simple ratio of atoms. It gives a simple ratio of atoms present in a given compound. Simple ratio of atoms. It is not the actual formula. This is your actual formula. This is the molecular formula is actual formula, which gives the actual number of atoms present in a given compound. We can say that. This actual number of atoms, but this does not give the actual number, but in certain case the molecular formula and the empirical formula is the same. Like here in this case it is the same. Like in this case NaCl molecular formula and empirical formula is the same. You cannot simplify it still further. It is the same, we can say that. So in certain case molecular formula and empirical formula is same, but in some cases you can still simplify it further, you can still divide it further, so that will give you the empirical formula. Alright, I hope so it is being clear. Thank you.